Hello, and welcome to the Quadratics Interpretation Overview. This is a study for Friday's exam, and what we want to go over is this basic idea of what a quadratic is, some of the vocabulary, and some of the basics on how to navigate and work some problems. So first we know that a quadratic function is in the shape of a parabola. As opposed to linear functions, which are straight lines, parabolas have that curved shape. And generally they're curving, opening upwards or opening downwards. But those shapes are called parabolas. Also, quadratics have y-intercepts and x-intercepts, just like a linear function. The y-intercept is going to be, of course, where it crosses the y-axis, right here. Okay, right there is where that crosses the y-axis. And then what's different about quadratics is that a lot of times they have more than one x-intercept. We can see here that this particular quadratic function has two x-intercepts. One here at looks maybe positive 1 or something like that, and maybe one here at positive 5. So that's certainly possible with parabolas. But what's interesting about having two x-intercepts is that some parabolas don't. Now the one we're looking at right now does have two, but here's an example of a parabola that only has one x-intercept right here. Okay, so instead of two x-intercepts, it only has one because that vertex is just touching the bottom of that x-intercept, so it's only crossing one time. And then yet still, we still have others that have no x-intercepts at all. In other words, the vertex is above the x-axis, so it never crosses. So these are three different possibilities. You might have two x-intercepts, only one, or even none, depending on where the parabola is located for a particular quadratic function. So that's something that we know for sure. But another thing about x-intercepts that we're going to talk about when we come back from spring break is that there's often additional vocabulary. Sometimes an x-intercept is also referred to as a zero, and there's a specific reason for that we'll discuss later. But for now, just remember that a zero is an x-intercept. Similarly with solutions. If we're looking at solutions of a quadratic function, we're generally looking at the x-intercepts. This is actually not always true. Okay, so maybe I should put a little asterisk by that one or a star by that. That's not always true, but in a lot of cases, a solution is an x-intercept. And then, of course, we also have roots. And roots is another term that refers to getting some value from an x-intercept. So all these vocabulary words are all part of what an x-intercept is. And if you see any of those vocabulary words, you should be thinking, okay, that's an x-intercept. It's going to be where it crosses that x-axis. Now, another thing that comes up with functions, or with quadratic functions, is the idea of the vertex. Vertexes generally have every quadratic function has either a maximum vertex or a minimum vertex. In this particular case, we have a minimum vertex. That vertex is going to be the lowest point on the quadratic graph. In other words, it's the lowest value for y, for a given x. And at that point, we're going to see it starting to go in the other direction. So this is an example of a minimum vertex, or the bottommost vertex. We can see this is kind of like a valley, and at the bottom of the valley, we have our lowest point. And then we also have another possibility, and this is called a maximum vertex. A maximum vertex is going to be like the top of the mountain, or the highest point. So every quadratic function generally has a vertex somewhere, and a lot of times you're asked to find the vertex given some other information about the quadratic function. So that kind of adds another little piece to the puzzle. We have our y-intercepts, our x-intercepts, our vertex is our lowest point of the parabola, but there's a little bit more that we want to talk about. But before we get into that, let me talk about the idea of like a mirror image. Here I put in a shape of a star right here. This star could be divided completely in half like this. And we're going to have a left side and a right side, right? And both sides match completely. We have complete mirror images on both sides of this star. See what's happening there? You can highlight either side and you see basically the same thing. We can even highlight both of them. But these two sides should be basically equivalent to each other. Any point we see on this side of the star should show up at the exact same distance away from this point on the star. If you're looking at this side right here, we should see an exact distance away. And this in the center is basically our mirror, or our mirror image. On one side we see the shape, on the other side we see its mirror image. Every quadratic function also has a mirror image of sorts, okay? And that mirror image is referred to as the axis of symmetry. It has a left side that basically does what it does, and then it has a mirror image on the right side of it, okay? And again, that's referred to as the axis of symmetry. I also like to refer to that as the mirror as well, okay? I just think of that as the mirror. It helps me understand it. And what's great about that is that any given point, like let's say this, the distance to the center is going to be exactly the same as the distance to the other side, okay? So this side, let's say side A, is going to be very much equal to side B. That's another thing, that's another property of quadratics that can help us learn more information about them. Okay? So given the axis of symmetry, we've pretty much covered all the vocabulary that we need to interpret quadratics. However, we haven't really looked at an equation yet. So there are we're not going to discuss everything to do with a quadratic equation, but this is the basic formula. Y equals ax squared plus bx plus c. And we know that basically when we have changes in basically the a value or the c value, we can see things happening to the quadratic. So what I want to do first is I want to show you what happens when we change values in a. We're going to start with a at 1. Okay, so let's talk about what's happening. I'm going to make a 2 and then 3. We're going to watch what happens to the quadratic. Let's watch what happens to the quadratic. Okay, there it is. There's 2. There's 3. Back down to 2. Back down to 1. What was happening here? What happened with that quadratic? As that number increased, we see it getting narrower, right? What happens if we go back to 1 and we actually make that smaller, like maybe 1/2 or 1/4 or 1/3 or 1/4 even? We can see that as that number increases, we can see that it becomes, as that number decreases, we see it becoming wider. So this gives us our first two properties of changes in the a value of a quadratic function. If a increases, we can see that it's going to become narrower. It's going to kind of shrink in like this. If the value of a decreases, we're going to see it become wider, and these two sides of this are going to increase. Okay, and I'm showing it to you again just so you can kind of see it happen. And then we can see it getting wider, right? Out like that. So that's the one thing that happens. But there's actually a little more that happens to this thing. Let's go back to our 1x squared. Here we have a value of 1 for a. I'm going to change that value to a -1. What do you think is going to happen now? Hey, look at that. Now it flipped. Everything else relatively stayed the same. However, now instead of having a positive 1 x squared plus bx plus c, now we have a -1 bx squared plus c. So instead of opening up, it now opens down. And we can see the big change is right here with this sign, okay, -1. So that's another thing that happens with a quadratic. So let's add some more rules. If a is greater than 0 or a positive number, it's going to open upwards. If a is less than 0 or a negative number, it's going to open down. All right, so now let's look at the c value. The c value is a constant, which means basically it's like our y-intercept, right? That's our y-intercept right there, okay? So what we're going to do with that c value is right now it's starting at 2. I'm going to increase that c value to 3 and to 4. Let's see what happens to the quadratic function. Do we expect it to get narrower or wider? Do we expect it to open up or down? Or do we expect it to do something different? Okay, oh, we're going to drop it down to 1, then to 0, then back up to 1, then back up to 2. What happened? We can see it, as that number decreases, we see that it seems to slide down or translate down. As we increase it, it translates up. Okay, up to 3, up to 4, and maybe back down again to 2. Okay, so the rule that we're going to look at here is that if c increases, if this value increases, it's going to translate up or shift upwards. If c decreases, it's going to translate down or shift down. All right, so basically that is a good summation of everything that happens with quadratics. and that's a pretty good overview. We have all of our vocabulary here that is involved with the quadratic function, as well as some of the changes in A and C that can occur as we're looking at problems. In part 2 of this video, I'm actually going to show you a few problems, and we're going to use what we've learned here to apply some solutions to those problems. Thank you very much for your time, and I look forward to seeing you again in part 2.